Hi, this is Mark Vina with SmartTech Research. I'm here at Infineon's OktoberTech event. I think it's the third or fourth event that I've been here at the Museum of History in good old San Jose. Are we in San Jose, actually? Mountain View. But I'm glad to be here. Infineon puts on quite an event. I'm here with Sam Jiha, the Executive Vice President of the Compute and Wireless business at Infineon. Just a small part of Infineon's business. I will say probably the most important business.
Oh, of course.
Sam.
Yeah.
So tell me about yourself. We'll get into kind of if we're only going to speak for like 13 or 14 minutes maybe. I want to get your impression of the IoT category, the value proposition that Infineon plays in that space. But let's talk about that right off the bat.
Yeah. So, Mark, good to see you. We always connect every few months here.
Yes.
And so about me, I'm a long-term veteran of Infineon / Cypress before that, the last 29 years. So I've watched
29 years.
Yeah, I've watched this technology evolve and the revolution. And what I love about Infineon is they are committed for the long haul. They really see, they know it's an investment. They're investing very heavily. They bought Cypress in order to start with a good strong point where we had microcontrollers and connectivity, and then they invested a lot more heavily in it, and obviously growing into the AI world and what we call it at the edge, because we can't compete in the cloud area, but we could certainly have some differentiated advantage with the AI at the edge.
I would say a lot of advantages myself, because the edge is where the action is, frankly. Yeah. Because the devices vary in size. They can be very small devices. They can be very large devices. Yeah. Here's a challenge that I see. When you look at the IoT space, it's a very, very fractured. It's a large market at the aggregate, but it's could be very fractionalized. So how do you map Infineon's capabilities, your solutions in that space? I mean, there's some parts of the IoT space that are very large from a volume standpoint. Others are a bit more boutique-ish and small. So how do you kind of map your strategy to the various products in that various usage models in that category?
Yeah. So we select markets and segments where we think we have a differentiated advantage. For example, smart homes, health, areas where you need connectivity, you need low power. You need, you need to have some advantage, and we can work actually here with the local leaders in the area. Like the Googles, Microsofts, Amazons. Some of the other companies, we can't mention their names. And, try to be a provider for for their services and really support them to win, and by making the right products for them. So,
well, you just said that it's kind of funny in that, because you guys ultimately are an ingredient company. Some OEM companies, some end user product companies don't mind saying, hey, there's Infineon technology in our product. Others, want to take, hey, this is our capability, it's our product that's facing the customer. But I know a little bit about that when you're a customer facing company. So when you kind of look at the IoT business, and one of the big initiatives at Infineon over the last couple of years has been digitalization, the digitalization of the world. Yes. So how do you kind of juxtapose that with that thematic strategy?
So one example, and you're going to see a demo later today, is we're looking at working with companies like EcoHealth, the guys that let's say you're in a remote area and you need intelligence at the edge. You need to connect to the Wi-Fi, but there's no Wi-Fi.
Yes.
So you want the smartness to be on the device. So one of the examples is you're taking a stethoscope, you're checking somebody's heart, and you're analyzing the data using AI at the edge right there. Locally, and not have to connect to Wi-Fi and all that. So we're looking at ways how we could help society stay healthy. As you know, the population is aging, and more than.
Don't say that about me.
No, not you, me as well. No, I think 22%. I think of the U.S. population is already over 60, and
that's a statistic that I really don't.
Yeah,
I don't want to.
It's okay.
We
just want to live a long life.
No, it's true.
So the idea is, how can we help society? How can we also help monitor and track I don't know, some of the fitness stuff, so you can really live a longer life. And that's how part of our impact there, what we could do to try and help out.
Now, what's really interesting is that, and I have not seen it yet because it's not going to open until later in the afternoon. You guys do a great showcase of various technology, and it's just and to be honest, it's just a small percentage of your total portfolio.
Yes.
But what's really great about Infineon is, and there's other companies that do it, it's not many companies, is that you're not an off the shelf, here's a piece of silicon, run for the races. You do a really good job of building usage models that, because a lot of the end user companies that embed your capabilities, they may not have large marketing departments. They kind of have an idea what they want to do, but they look to partner with you folks because you said, hey, here's a capability that when we map it to your usage model, you use that one medical example. That's really interesting to me. So I'm looking forward to the afternoon and seeing that.
So the days of just making a chip and giving it to somebody and say good luck,
those days are over.
Those days are over. What we really try to do is try to offer a full system solution end to end to make it easier for the customers to adapt it and use it in good examples. So there were two examples. One, we did this. The convection oven, and it has 17 different Infineon products, but we could showcase where you can control and cook, using your phone, and
That's cool.
and it tells you when the recipe is ready and all that, just to make life easier for people. Other examples is we try to offer end-to-end models, like whether we teach the model how to to be smarter, or whether you have your own data, and we just want to make sure your data is secure, and then you can use our product, our PSOC Edge product, which is as a solution for for whatever different application you may have.
So as we kind of wrap this up, when you look at the IoT space and it's so big and fractionalized, there has to, and we could spend an hour talking about this, but are there a couple of areas that you see particular growth?
Yes, absolutely. What we try to do, and I will answer the areas, but before I answer the areas, what we're trying to become really good at is, first of all, voice and vision, right? Those are like the areas where it could help a lot, right? So when you walk into a room, they'd want to know that it's Mark Vina versus Sam Jaha, or and so that's differentiated, and that's important for many people in security camera areas, etc. We're seeing a lot of that. Voice is also very important because the world always head toward low power, right? So for low power, you want to keep the device sleeping as long as possible, but you want to wake it up only when it recognizes your voice. So we try to use our low power device as like the interface to the system. So, your TV is almost off most of the time or half asleep. And then when you speak to it, then it just wakes up using, AI, and it's like, oh, okay, Mark's speaking to me. So now I'm awake and I'm going to wake up. The growth areas but continue to be a lot in smart homes. We're seeing a lot of that, and I used to wonder if does matter, and now I really am a strong believer that yes, it matters, because you want to connect all the devices from the different companies to talk to each other
in a highly interoperable way.
Yeah, exactly.
And not remember what word you have to use to activate the device.
Yeah, exactly. Right. So it recognizes you by voice, your voice, and a different device.
Well, and not to throw a bone to the Matter initiative, which you guys are behind, is that there's also a security layer that if you're a Matter certified product, it's a level of security that a lot of non-Matter IoT products don't have.
One of the things we're super proud of is we're actually the first company that are offering an MCU with what we call level 4 security. Level 4 security is the most advanced security. And the reason we started investing heavily in that, in addition to being a very strong company in security, is our customers really value the most their data that they've collected and spent millions of dollars doing, and they want to protect their data. They don't want somebody else to take it. So we worked super hard to provide the highest level of security with our MCUs, and that seems to be an angle that's important for people.
Oh, it's huge.
You also don't want to be hacked, right? I mean,
well, it's a hacking thing, but let's face it, for AI to really be compelling, you'll want to put more and more of your own trusted information on there, and frankly, you don't want to be in a situation where, it's very productive for me, but that information becomes at risk.
Exactly.
Any closing comments?
Just keep in mind, and maybe for the audience, is we're continuing to invest very heavily in edge AI and in area what we're calling AIoT, which is AI at the
At the edge.
Yeah, AI at the edge of things, and we're continuing to invest in areas that are good for people, good for the environment, and and you will see us grow in that area quite a bit because we're investing very, very heavily in it.
That's great. Well, I'm looking forward to seeing your showcase, and I appreciate you stopping by, Sam.
Yeah, good luck today. Thank you.
Thanks very much.
All right.
Hi, this is Mark Vina with Smart Tech Research with my second interview with a very important person at Infineon's OktoberTech events. I'm here with Janis Schweiswald. Did I get it right?
That's perfect. Yes.
I win a cookie here at the event. I have a person off camera that will pass on that cookie to me. This is a very, very important business that you handle at Infineon, Janis. And the thing that really is interesting to me, and I've written about this, is that it's kind of a behind-the-scenes technology that may not be business that's not quite obvious to mainstream or consumer users, but it's so incredibly important. Power efficiency, because of sustainability, even touches on digitalization to a degree. But with this rush toward AI, with data centers requiring more and more efficient power, but even that business affect EVs and other things that require battery life, to optimize that battery life as much as possible. So let's talk about that, and especially your 300 millimeter capability in this space. We'll get into that in a little bit in detail, but at a high level, talk to me about the GaN business in general and what that really means to the average person.
So power delivery is super critical, as you just said, right? So whatever device you have, electronic device you have at home, whether it's your smartphone, your notebook that you have, your computer, desktop computer maybe, your TV, your music installation, whatever it is, it needs power, right? And without power, it will not work. And so therefore, what's super important is that we have this power delivery in place, and we do this as efficient as possible so that we do not consume meaningless much resources. So this is super important for everyone at home. That's one element. But then also, how do we generate the power? How do we bring the power to you, to the consumer? And how is it then consumed, right? And in all the three steps, of course, power semiconductors are important. Without power semiconductor, nothing here works. So without the power semiconductor space, whether it's silicon or gallium nitride that we will talk about, no electronic device that you have will ever work. So it's a behind the scenes, indeed, right? We talk a lot about the processes and so on, and hardly about the power delivery. But without the power delivery, there's no AI servers, there is no servers anyway, there's no email, there's no web browsing, nothing. So therefore, super critical technology.
And you know what's interesting about this? I think the average person gets, battery life in an EV, for example, is important. But even in small devices,
indeed,
where like in the IoT space, cameras, wireless devices that you don't have a constant power source, you want to make sure that you're getting great battery life in an IoT camera or an IoT smart lock, or you don't want to keep replacing batteries all the time. So really, there's a whole breadth of products and categories of products that this applies to. It's not just big stuff.
Good point. Exactly right. So either it's on the high power side, right, on the generation, when we talk about big solar farms. So this is, of course, super high power, many kilowatts that are needed there. Or it is like this thing here, right? That is handheld
I got to check to see
if
there's an Infineon technology. I got to check with the manufacturer.
I hope it is. So it could be. There is, of course, here is also important that this lasts for as long as possible, right? For convenience reasons. So therefore, it's small devices, low power, milliwatts to many kilowatts. So that's where the entire power semiconductor space is residing. And Infineon is delivering across the entire spectrum, of course.
Yes, and has been for some time. It just keeps, the offerings just keep getting better and better. So what are, at a high level, the advantages of GaN? Just, from a non-scientific, non-technical engineer type of way.
Yeah. So when I get back to we generate power, we transmit power, and we consume power, it just becomes more efficient everywhere, right? In the generation, when we talk about the solar farms, as mentioned, for example, or solar microinverters that everybody might have at home, then this becomes more efficient. On the transmission, we can be more efficient, and in the consumption, we can be more efficient. Let's think about an EV, for example, an onboard charger. We can improve the efficiency level from already pretty high levels of 95% efficient to a 97, 98% efficient. It sounds like just 2%, but really the amount of power that is wasted is reduced by half.
Right.
So it's really a lot of power consumption that goes down. Yeah, and so we use the energy more efficient. That's one thing. And the other thing is we can build things smaller. Like we all have chargers for our smartphones, of our laptops and notebooks. A couple of years ago, the 65 watt charger was pretty big. Now you get these neat small devices with multiple
that's interesting.
outputs.
I've noticed a trend in that in the old days, 3-4 years ago. They were almost like power bricks.
Exactly.
And especially as you want to charge multiple devices off a small power, and I probably have a couple of them in my bag, they've gotten incredibly small.
Yeah, and that's enabled by new power technologies like gallium nitride. Because it's so efficient, can go to higher switching frequency, that shrinks the design, everything becomes smaller, and can handle more power in smaller space. That's what GaN can do.
So let's talk about the big news specific to what you're doing with 300 millimeter GaN capability.
Yeah.
Why is that so important? The 300 millimeter piece.
Of course, what we always want to do, we want to bring new technologies, but they also need to be very cost competitive, right? A customer will only take our gallium nitride technology if it's cost competitive.
If it's cost effective, right?
Yeah, what is already in the market. Going to bigger wafer diameters simply brings down the cost. And the maximum you can do is really the 300 millimeter. That's what the semiconductor industry has worked on for decades, right? That's the biggest wafer diameter you can do, and that delivers you the best cost position. But then also you get the best tools at this point in time in this wafer diameter. So also processing quality, reliability becomes better. So the devices themselves become better just because you move to the 300 millimeter wafer diameter. So that's a nice thing. And with that, you also have a lot of capacity in place, right? The markets are huge, right? How many smartphones are shipped? This device needs power, and we want to bring GaN everywhere. So we need this big volume and capacities, and ideally you do this in 300 millimeter. So therefore 300 millimeter is really the way to go. Eventually one wants to bring pretty much every technology there if possible. And that's the good thing about GaN. It's possible, as we have shown, with working devices on the 300 millimeter device. Wafer.
My back appreciates that because I don't like to walk around in my bag of tricks with these big hulky bricks. You know, hopefully we'll never use that term again. A brick power supply. Any last words to share with the audience in terms of maybe the key messages you want to impart from why Infineon plays such a pivotal role in this category?
Yeah, we are very committed to new technologies. We were always leading in new power technologies, and also for gallium nitride, which is, besides silicon carbide, another wide bandgap material. We want to lead here when it comes to new technologies. And you will see, as gallium nitride is not just in your charger for your smartphone or your notebook and laptop, you will also see it in many applications, home appliances, and this will contribute to use less energy, help in this decarbonization effort that we have, and that is, I think, a big benefit for every consumer out there.
Well, and the thing that just occurred to me just a second ago is even when you make an improvement of 2, 3, 4%, when you apply that from a scale standpoint by the hundreds of thousands of millions of units that appear, that has an incredible aggregate reduction from a decarbonization standpoint.
Yes.
Well, this is great stuff, and I look forward to hearing more about you folks in this category, and I appreciate your stopping by.
Thank you very much.
Thanks very much. Thank you again.
Thanks.
Hi, this is Mark Vina with Smart Tech Research. My third interview with an Infineon executive. I'm here with Peter Schaefer, the EVP, I want to get your title right, of the Automotive and CSO of the Automotive Group. Welcome to the SmartTechCheck podcast, Peter. Couple of questions for you. OktoberTech is such an interesting event. I've been coming for the last 3 years or so. It's been around for a long period of time. Talk to me about some of the latest technology trends in automotive, whether it's EVs, even non-EVs, frankly, because it's been, I forget the executive who said that a car is nothing but a computer on wheels. from a technology standpoint. Then we'll talk about the role that Infineon plays in optimizing the today's and the future driving experience.
Yeah. So actually, the cars as well as the trucks or agriculture vehicles are in a huge transformation towards decarbonization and digitalization. And at the end of that transformation, we will see that the cars and the trucks, they will be all electrical, they will be autonomous, they will be connected, and they will be cyber secured. And actually, there are three areas where we have to invest a lot of energy and time in order to make this happen. The first one is the electric drivetrain. So here we need to introduce semiconductor solutions that make the drivetrain even more efficient. We need to work on battery management because battery is the most expensive part in an EV, and make that as useful as possible. And then, of course, make the charging faster. So that's on the drivetrain side. Autonomous driving is a big topic. We see two different speeds. One is adding in automated driving features one by one, like level 2++, and marching towards level 3. And the other thing is the autonomous driving. So very focused on getting robocars out there. And the third one is, how do we get the cars in an architecture that you can, during the lifetime, update software and services so that consumers can really get more and more value over time, even in the car.
Right. So let's talk about the autonomous driving piece for a second, because there's still a lot of skeptics out there in terms of, how safe it is.
Yeah.
I think that's obviously there's a learning curve, but we've come a long way over the last even 7 years in terms of the autonomous driving experience becoming a lot more practical. What's your view on that in terms of when Infineon believes that the capabilities were in place to really provide a highly safe experience?
Yeah. We need to differentiate two topics on this. First, there needs to be a lot of innovation on the software side, on the sensor fusion, on making decisions using AI. That's the one area. The second area is, how do we make the whole system reliable, that we don't have failures occurring? And that's two topics, but they are deeply entrenched.
Right.
So we need dependability on the electronics so that we have fail operational modes in case something is failing. And then we need to drive the innovation on making the right decisions for the car. When we achieve what level, out to be seen. I'm very optimistic. I see a lot of progress. I see a lot of progress in this step-by-step approach, making it more comfortable to drive. But also in the US and in China, we see a lot of good progress on the full autonomous driving.
Now, on the power side, and specifically on the battery side, Infineon's it's been in this category for a long period of time. Consumers, when they're looking at EVs, they want to make sure that they can get a car with an EV with long enough range so they don't have to charge all the time. There's more charging stations built. The U.S. government has played a role in spending lots and lots of dollars building up the infrastructure. But what is Infineon specifically doing to optimize that battery experience? You have recently done some big announcements with 300 millimeter GaN technology, which may play a role in this. Yes. I suspect it will. But from your perspective, what are the kind of big things that are happening that will, give people comfort levels? Hey, if I buy an EV, it's a much more not only a sustainable experience from an environment standpoint, but it's less expensive in the long term. Right. And it provides a much more reliable experience to have that as your primary car, for example.
Yeah. So it's a wide range.
I know. And we only have a few minutes.
If we take the EV, first of all, you want to charge the EV fast, right? Here, gallium nitride will play a role, and us taking it to 12-inch, so a bigger geometry for the manufacturing, drives down the cost for this, and we can make it cheaper. Then for the efficiency of the inverter and the drivetrain, here silicon carbide plays an important role. It will be introduced all over, and with this we can get efficiency out of the system and need less battery. So you can either shrink the battery, or you can have a longer range out there. Yeah.
And finally, what kind of things do you think we'll see from Infineon over the, let's say, next few months, maybe upwards of the next 12 months, that people should pay attention to?
Yeah. So on the electric drivetrain, we just announced this week that we introduce what we call fusion module, high voltage module for the inverter for the electric vehicle. And what we do with this is in contrast to just pushing everything on the highest efficiency, we need to be careful that the cost of the EV is very affordable,
Reasonable.
because the next wave in growth in EV very likely is more on the low end. People want to add in smaller cars which are EV, so we have to be very cost conscious. The high voltage fusion module is a mix between silicon carbide and silicon, and with this is much more affordable. So those topics we will see in many areas. Other example, we are launching the Aurix TC4X with a parallel processing unit. What that enables is that we can drive model-based control in many applications in the car. Super example is battery management, where we can do more than just control the battery system, but also screen and hear out how is the battery doing, how is the health of the battery, is there anything critical developing, and making sure that the battery is well treated and lasts as long as possible. And this will also add in to is your EV car in 5 years, what is it worth, because the battery needs to be in a good state of health.
Well, I mean, algorithms and AI can play a role in that, in terms of predictability on the lifespan of the battery. Really, really cool stuff.
Yep.
Thank you again, Peter, for spending some time with us, and I'm sure I'll see you again very shortly.
Thanks for having me.
Thanks again.
Bye.
Hi, I'm Kevin Hughes. I'm a product manager at Infineon Technologies. I'm here with our Inductive cooktop demo. So this is a really nice demonstration of Infineon's broad portfolio and how we can bring it all together to create a really nice solution. So we actually have 17 different products in here. We have everything from our IGBTs, power MOSFETs, and inverter control on this board here. So that's what's controlling the inductive hub. Then we have a connectivity board. So this has both Wi-Fi and Bluetooth connectivity, which allows us to pair with a remote app so you can control your cooktop remotely. It's also got microphones, so you can actually do voice commands. So instead of using separate Alexa to do set timers, you can talk directly to your cooktop, set timers, set controls for easy hands-off use. And then we have our CapSense technology, which enables a really high-performance human-machine interface. So this allows a really nice, clean design where you can have easy control, and it even works when it's wet. So if you have some spill from when you're cooking pasta, or if your hands are dirty or greasy, there's no issue. You can still control everything inside the cooktop. So we're able to bring all this together to complete basically a full solution, ready to go to production. This is a reference kit that we have available. So if there's any interest, you can also go to our website and get more information.
Hi, I'm Surinder. I'm a product development engineer with the Infineon Power Modules team. So here we are going to show about a 2000 amp vertical power delivery solution we have. So we start with the state-of-the-art GPU today that takes about 1000 amps of current in a lateral power solution. With the processor sitting in the middle, we have multiple power stages, multiple rows of power stages, taking in thousands of amps with the PDN over 100 micro ohms. Then with the next generation of processors taking twice the amount of power in the same board space, we have come up with an innovative power solution where we have a 2 amps per millimeter square power module, where just by placing the modules on the bottom side, we take advantage of vertical power delivery, bringing in the losses by 70% lower. Effectively, that means we would be saving hundreds of watts in single board. That will translate to many megawatt hour in a data center over the period of over a single year. So in addition to it, this module is actually very light. It gives about 2 amps per millimeter square of power density, and this is how we power AI for the next generation. Thank you.